Hi, I'm Ron Lane with Circadian Crop Sciences. I founded Circadian Crop Sciences in 2018 after retiring from UC Davis, the Plant Sciences Department, um, with the goal of providing minimum risk pesticides uh, to regular farmers and getting them tested the way you would fully registered pesticides to ensure that they work properly. Um, so what is a pesticide, first of all? The Federal Insecticide, Fungicide, and Rodenticide Act, also known as FIFRA, is the primary federal law governing pesticide use in the United States. A pesticide is defined within FIFRA, Section 2U, as any substance or mixture of substances intended for preventing, destroying, repelling, or mitigating any pest. Any substance or mixture of substance intended for use as a plant regulator, defoliant, or desiccant, and any nitrogen stabilizer, which doesn't really concern us. So you've probably used pesticides, and up in the right-hand corner you see a label for Tenic 15G. Note it has a danger, keep out of reach of children, which is very common on pesticide labels. But then it says danger, poison, and it has the skull and crossbones. So you know that if you see the skull and crossbones, it's a bona fide poison, doesn't take much to kill you. So an EPA registered pesticide can be very toxic, to only be used by professionals. And this product here, you would have to, it's a restricted use product, so only a licensed individual can purchase and use this product. Products over time can lose their registration, so I don't believe that Tenic 15G that you can use it anymore. Then note orthene. Orthene is an organophosphate. It bears a caution label, so you don't have to have a special license or certificate to apply this product. And you know, it's very commonly used. And then you see in the middle bottom of the page a 25B compliant pesticide. So what is a minimum risk pesticide? The EPA has exempted certain minimum risk pesticides from the registration requirement of the Federal Insecticide, Fungicide, and Rodenticide Act. And this exemption is located in 40 CFR 152.25 F. So some of the criteria for qualifying as a minimum risk pesticide is that the active ingredients must be listed in 40 CFR 152.25 F1, and there are about 45 active ingredients available for use in minimum risk pesticides. These ingredients weren't just picked out of a hat, they just didn't pull them out of their ear or whatever. You know, beer and pizza isn't on the list. These are ingredients that have shown some efficacy, or they wouldn't have picked them as active ingredients. Inert ingredients with a minimum risk pesticide may include chemicals that are also noted in various provisions of FIFRA, and that includes several hundred ingredients are available to be used as inert ingredients. And the inert ingredients are important. They can make all the difference in the world with the active ingredient actually working. The EPA also has specific labeling requirements, and most states require registrations of minimum risk pesticides. And a state like California, they may have additional requirements of minimum risk pesticides. I guess the big question is, do minimum risk pesticides work? I mean, if it doesn't work, what's the point of using it? And as I said before, the active ingredients were chosen for a reason. They had shown efficacy in other studies. But with minimum risk pesticides, there's no guarantees that they work. So with EPA registered pesticides, do they work? I've been to many conferences over the years and listened to many presentations on the results of this field trial or that field trial. And I can tell you that looking at those results, many EPA registered pesticides have no efficacy whatsoever for a particular disease or pest on its label. So, at one time they had to prove efficacy, but that's it. Just the one time, and if the pest gains resistance, they can still pump it out onto the market as if it actually worked. So neither one has any guarantees as far as efficacy goes. What you should do is look at some of these studies. So I'm going to tell you about one of the minimum risk active ingredients here, and potassium sorbate. It's one of the world's leading food preservatives. It was isolated from mountain ash berries in the mid-19th century. Literally over 1,000 published studies have shown efficacy against a wide range of fungi, bacteria, and including pathogens. It has 10 documented modes of action. It inhibits spore germination by competing with certain amino acids, and it's thought to alter spore membrane permeability, cation transfer function, and interferes with the activity of certain enzymes. It compromises the integrity of cell walls and membranes. It inhibits cell metabolism by decreasing carbon assimilation, inhibiting certain enzymes, altering cellular pH, and blocking uptake of certain amino acids, glucose, and nutrients. And so here's a table that goes over some of the modes of action that have been documented with potassium sorbate, in this case against E. coli. And you can see the references for the studies that document that. Here's a field trial of a potassium sorbate containing fungicide, bactericide. This pesticide is called All-Phase. It was conducted on Chardonnay grapes, and it reduced the mean severity of powdery mildew on Chardonnay grapes to 10%, whereas the controls were 52.5%. And this was done with very high disease pressure and no wetting agent or no rotation with other chemicals in the spray program. So when looking at other products that had been evaluated, they all had, or most of them had, wetting agents and were rotated with other chemicals. Here's All-Phase used to control almond scab, and it reduced the incidence of almond scab with just 3 applications, one in May, June, and the end of June. It wasn't a perfect result, but there was some efficacy there with just a limited number of sprays. Now here we added in a surfactant, and this was done by Collins Ag Research in Hubbard, Oregon, and there they tested it for controlling downy mildew on hops, and they had 0 downy mildew. This is a study that was done by the Cal Poly Strawberry Center. Once again, the All-Phase had a surfactant mixed in with it, and it had 99.9% reduction in disease incidence and severity, and it had the lowest mean incidence of disease and severity of any product that they tested. And that included, the traditional EPA registered pesticides. So in this case, it worked very well. This is a reference to that study. It was conducted by Kyle Blauer at the site, and you can see here that if you look at the incidence of all the products tested, all phase with high wet had the lowest incidence and the lowest severity, and it was all statistically significant. There are other minimum risk pesticides. Pesticides containing mint oil and essential oils, can work very well. With mint oil, there are terpenes in mint oil with insecticidal and mitocidal and antimicrobial properties. Two of the most prominent ones would be menthol and menthone. And many studies show they act as neurotoxins on insects, inhibiting insect cholinesterase, modifying gamma aminobutyric acid receptors, which has the same site activity as IRAC category 2. The IRAC, that stands for Insect Resistance Activity Committee. But they're category 2. It's the same site, but it does the opposite as their IRAC category 2. It stimulates the receptors so that they can't fire off, actually. It also interferes with octopamine, which is the same activity as IRAC category 19. And octopamine can act as a neurohormone, neuromodulator, and neurotransmitter in insects. So the combined activities of these products, of these mode of actions within just mint oil, covers 3 documented modes of action. So we had a product called, or we have a product called Circadian Sunrise. It was included in a powdery mildew field trial for controlling powdery mildew on Chardonnay grapes, and it was applied at 2 ounces per gallon, and there was 0 powdery mildew, 0 incidence, and 0 disease severity. Here it was used in a field trial for downy mildew on hops. Didn't have a lot of reduction in downy mildew, but it did have statistically significant reduction in downy mildew. Here it was used on bunch rots in grapes, and it reduced bunch rot by over 40%, which, we'd like to do better, but I was not really expecting much activity at all in preventing bunch rot, and it was only applied 3 times throughout the course of the study. So, if it had been applied more frequently, I would have expected better results. The efficacy of mint oil on aphids and insects, those modes of action are well documented, and here you can see we sprayed cotton melon aphids on cucumbers, and the kill was close to 100%. It was at least, you might be able to find a living aphid, but it worked really well. Here I had a retired senior research assistant from UC Davis, who's also an entomologist, test Circadian Sunrise on 2-spotted spider mites. He did the spray, and he filmed a video, which this link can lead you to a video that will show you, how he got a real good kill on 2-spotted spider mites with the peppermint oil-based Circadian Sunrise. Now, some advantages of minimum risk pesticides. One is that many work well with biological pest control, and that's because many or most are very, they don't have a long residual sort of activity. So in the case of a mint oil-based pesticide, it's going to volatilize, and as soon as the spray is dried, you could reintroduce beneficial insects or mites. They also, we know that the peppermint oil-based sprays, when they're sprayed directly on parasitoids within their host. They do not harm that parasitoid, so they can come out of the host and then they can go around and continue to attack any host that the pesticide failed to kill. Something like potassium sorbate can control your powdery mildew, but it won't harm your beneficial mites or insects. There is no pesticide use reporting requirement in California for when you use minimum risk pesticides. So, it saves you a little paperwork there. It's exempt from EPA residue tolerances. The residues are not considered a pesticide. So you're basically growing pesticide free when you're using minimum risk pesticides. There's no re-entry interval required on the label when you have a minimum risk pesticide, but many manufacturers do put a re-entry interval on the product. On my products, I put a 4-hour, well, I put down until dry, because somebody could be allergic to mint oil or to the potassium sorbate. So it's just smarter to let the spray dry. There's no harvest interval that's required with minimum risk pesticides, and they're made from sustainable sources. So, if you're into sustainable agriculture, these will not jeopardize your status as having a sustainable operation. They're also excellent to use in sensitive areas like close to schools, near residential areas, etc. Some disadvantages of minimum risk pesticides is there's only so many active ingredients, so there's only so many modes of action. So it's not like we want to do away with all the other types of pesticides out there. As a grower, I've been a grower, you want to have as many modes of action in your toolbox as possible. So these are good options for you. Another disadvantage, and it's not so much a disadvantage, is that, well, it is a disadvantage. There's less testing. Many of the 25B registrations, the people that have put their products together have not put them into any field trials to see how they stack up against other products out there on the market. So, to me, having some field trials out there to show that it works is important as a grower, so look for that. In conclusion, minimum risk pesticides, they're perfectly legal for use on agricultural crops. Check their labels. Still exercise caution when applying them as you would with any other pesticides. They do afford you more flexibility on your farm as far as management because of the short or no reentry intervals and harvest intervals, and they do expand the modes of actions that are available to growers. So look at the science and don't be afraid to give minimum risk pesticides a try. Thank you very much.